Hey guys, so this video is going to be over the lesson for 3B-4, which is proportional versus non-proportional relationships. Proportional relationships was the topic that we've been learning for quite a while now. They are graphs and tables that basically start from 0 and go up by a constant rate of change. But whenever we have something that does not go up by or does not start at 0 and does not have a constant rate, we call those non-proportional. It's just the opposite of proportional. So let's start talking. This is a definition for just proportional relationships. So proportional relationships, first of all, let's go ahead and write the word proportional. Proportional relationships is when one quantity varies directly I'm sorry, if I write sloppy, you can pause or ask somebody, but it says varies directly with another quantity. Basically, varies directly means that it is changing at a constant rate. And it also, that's it. It pretty much starts at 0, varies at a constant rate. So an example of something starting at 0 and varying at a constant rate would be every time you earn 10 stars at Starbucks, you earn 1 free drink. It didn't say you just start out with free drinks because they just feel like it. You have to earn 10 stars to earn a free drink. And then it just keeps going. So, for instance, this example would have an equation of you would get 1 free drink every time you get 10 stars. Okay? So, let's look at an example of something that is non-proportional. So, these are all proportional examples. And these are all non-proportional examples. So for instance, over here we had a constant rate and we started with 0 free drinks. Over here in this example, it says you pay $25 to join Planet Fitness, which is a workout place, a gym, and $10 a month after that. So you first pay $25 before you work out at all, and then you pay $10 per month. So it is this right here would be the rate, and this, which we know that 10 was the rate in our first one, the rate of change. This one is the rate of change. In this scenario, $25 is our initial value, which we call our y-intercept. Our thing for this one would look different. Our rate would be $10 a month, yes, but we would have had to start off with that $25 to begin with. We didn't have to pay $25 any times than just one. That's why there's no number or variable multiplied to it. It was just a one-time fee. But then we have the rate of $10 per hour. Okay, so let's talk about some tables and how they're going to look different. We are not going to use these examples up at the top, the word problems. I'm going to make up my own. So I know that if proportional graphs have to go through the origin, they start off and they make table, like they go up, they vary directly. I can start off at the origin, like this. And then I could count 1, 2, 3 up at the top. Those could be my x values. My y values could look like this. They could go 2 and 4 and 6. So if I were graphing this on the graph, I would start here at the 0. I'd go over 1 up to the 2, over to the 2, up to the 4. I'm using these numbers as coordinates to help me plot. Over to the 3 and up to the 6. So I know my dots are not perfect, and if your dots are not perfect, it's okay. But as long as you kind of have a line that looks like this. Wow, good job, Miss Garza. You couldn't even see. So I started at 0. This dot would be 1, 2. This dot right here would be 2, 4. This dot right here would be 3, 6. Oh, sorry, 3, 6. Yep. And then it's going up like this. So the rate on this one would be 2. It's starting at 0. So here's a quick little equation for this. If the rate is 2, that's my equation. Okay, let's do an example of a non-proportional table. So I said that a proportional graph has to go through the origin. So if we have a graph that doesn't go through the origin, we could start on any one of these dots here. How about 3? We'll start with the 3. We'll start right here. And instead of going up, how about I go like this? And I try to make my dot go 2 spots over. See how this would have boxes here? I would have gone 2 spots over like this. And let's make it go 2 spots over one more time, like that. So on this one, I drew my graph first, and I'm going to plot the stuff in the table next. I'm going to see if I can continue my pattern, even though I only drew 3 dots. So the first dot is not going to be 0, 0, and that's part of why this graph is not proportional. It's actually going to be 0, 2, 3. It's going to be 0, 3. Which is funny because yesterday, or not yesterday, but a little while ago, we were talking about how this right here is a y-intercept. Okay, it's not going through 0 anymore, it's going through 3. These are the y-intercepts. It's just not 0 anymore, so it's not proportional. Now let's talk about how it would keep going. So it looks like my next x doesn't come in until 2. And then the next x doesn't come in until 4. It also looks like the next y for this one was 4, and this one was 5. So you could kind of continue the pattern, and it would go 2, 4, 6, 3, 4, 5, 6. So 6, 6 would be the next dot, and it'd be about right here, which makes sense because it's pretty much following my pattern. All right, let's talk about some specifics of proportional relationships. It says a proportional relationship can be represented by the equation in the form of y equals mx, with the m being our rate. By the way, side note, this rate is actually going up by 1/2. Or, did I do these right? 2, 4, 4, 5. Oh, yes. And so that's what's weird about this. 2, 4, 6. 1, 2, 3. Yeah. Okay, and that's what's weird about this. Usually over here you could, I'm so sorry. Usually over here you could tell really easily where your, what your pattern was. You could tell that we were going up by 2s. Over here it makes it a little bit more complicated to calculate the pattern. You're gonna have to really look at the graphs on this. I can tell I'm going up by 1/2. I'm not going up by a full dot every time I move over. So my rate would have been 1/2, then I put the x, and this one was a funky one because it didn't start at 0, so I can't make it proportional like this. I kind of have to use the same little scenario right here and put +3. Now this part is confusing to you. We will get to that more later. Today's notes were mainly focused on what makes a proportional relationship different from a non-proportional relationship. Proportional goes through the origin, straight line. Non-proportional does not have to go through the origin. This just so happens to be a straight line. However, if you ever run into any curved lines, they are not proportional. All right, so the graph of a proportional relationship, we just talked about that, must go through the origin. It also must have a constant rate. All right, and so let's talk about what it takes to be a non-proportional relationship. You don't have to go through the origin, and technically you don't have to have a constant rate, which makes the line kind of curvy like that. You don't have to draw that. That's for a non-proportional relationship, okay? So remember, that's what it takes to be proportional. The opposite is what it takes to be non-proportional. For a table, if you're ever looking for a table, remember you want to find the origin, which is 0, 0 in a table. You also want to be able to find the rate really easy by taking y and dividing it by x. Okay, that is how you find the rate of a proportional graph. See, I could have taken 6 divided by 3 and found that my rate was 2, but over here, I can't do 6 divided by 6 to get 1/2. It just doesn't work. That's because this is non-proportional and this is. All right, that is your notes for proportional relationships versus non-proportional relationships.